like this I saw back in middle school. That's linear. Now how many answers am I expecting if I solve that? One. That's what the degree tells me. It tells me expect one. That right there tells me before I even start. Just get one answer. And of course, from the middle school, right quickly, you know the answer. Here it is. X is equal to, what is that, -3? And you get one answer, you're finished. Done. Now the quadratic, how about a quadratic? What's now going on with a quadratic? That's another vocabulary word. It's not linear this time, it's quadratic. What does a quadratic sort of look like? Who has an idea? Yeah.
Like x squared plus x.
She's giving a specific example, exactly. They look like this, and she mentioned this, ax squared, your textbook gives it like this, where now the highest exponent, called the degree, is 2. And usually they're in the form something like ax squared plus bx plus c is equal to 0. Now these are a little bit tougher at times, and by the way, since the degree is 2, how many answers are you to expect?
2.
You gotta get 2. And there's different ways to get those 2. Now before I leave this and jump into some of your examples there, suppose it looked like this. I'm gonna make up one. Now suppose the equation looked like that. X cubed plus x plus 4x plus 4. Can I do anything with it? Can I do anything at all with it? By the way, how many answers right now are you expecting if it did have an x cubed? You gotta get 3 answers. That's the degree. So whatever that exponent is, so on the quiz next Wednesday, if you see an x to the 10th, get scared. You're gonna get 10 answers. So that degree will tell you ahead of time how many answers you must show if you have one like that. By the way, guys, this x cubed plus x plus 4x plus 4, I just made that right quickly. I think many students could see that, Professor, you could clean it up a little bit. I'm expecting 3 answers because the degree is 3, the highest exponent. But I could have cleaned this up and called this x cubed plus, combine some like terms, 5x plus 4. That would help some. I just collected these. But still, with an x cubed plus 5x plus 4, that's still tough to deal with. But you expect 3 answers. Now let me drop back, and then we'll take some a look at some of the worksheet problems here. Suppose this had been this. Let's go back to the quadratic. Let's go back to the degree. The degree is 2. I'm expecting 2 answers now. I changed it from a cubic. Now, could I do more with this? Now I'm expecting 2 answers. Not 3. I dropped back to a 2 for a reason. Now, can anyone tell me before I jump in and do what I got to do tonight? That's a quadratic. X squared. Expecting 2 answers. Does anyone think they can recall from somewhere? How are you going to get those 2 answers? Go for it.
It would be like a negative and a positive.
It could be a negative and a positive. Now, how am I going to find these specific numbers there? I see another hand going up. Yes.
What multiplies to 4 and adds to make 5? Or negative 5, I can't read.
Right here, x squared plus 5x plus 4. You're saying now, in her mind, she's saying, wait, Professor, I sort of remember I'm trying to multiply 2 numbers together to get a 4, but they must add up to a 5. Now, are there 2 numbers out there when you multiply them together you get a 4?
Yeah.
But at the same time, you add them and get a 5?
Yeah.
And what was that called back in middle school? I guess middle school now teaches this, probably elementary school. Factoring. You have to know your factoring skills. So this one, with her help, would look like, let's see if this marker will work out for me, x plus 4 times what? X plus 1, this is what she's telling me. She says, Professor, there it is factored. Now though, I don't have the answers yet. This degree says you better get 2 answers. She's helped me out somewhat. Now, does anyone recall now what do I do next to find those 2 answers? Go for it.
Set them equal to 0.
Set each one of these factors, they're called factors, guys. Set each factor equal to 0. They call it the zero product property. that allows me to do that. Then solve for x, easily done here, -4. Here, easily done, -1. If we have no mistake. I hope I don't have a mistake here. So guys, I finally have the two answers, -4, -1, for that quadratic. Done. Now, the cubic that I erased, I may stay away from the cubic tonight. Just sort of stick with linear and quadratics and some of those variations of a linear and a quadratic for tonight. And then jump into some of the tougher ones later on. But right there, we have one. Now, that said, let's call this letter D here. I'd like to try now, and it seems like I brought one in from the handout. Here we go. Here we go. I'd like to try this one. 2x squared, try and get some input from you guys, is equal to 4x plus 1. That's on your handout. Letter H. 2x squared is equal to 4x plus 1. Is that a quadratic? Is the degree 2? Is that the highest exponent? When you look at the exponents up there, is the highest exponent 2? That makes it a quadratic. So with her help, she says, Professor, she gave me this factoring here to find the two answers for this one. Now this one, now help me out. How am I going to find the two answers here? It's a quadratic. Can I do the factoring again like she suggested?
Yeah.
And first, what might I want to do? And I see some hands going up. What might you want to do first? Go for it.
Put everything on one side.
Beautiful. 2x squared, subtract 4x. He said, Professor, rewrite that. Everything on one side and one side 0. You got to have that one side be a 0 here. Now, what she gave me, which I thought was beautiful on the last one, to get those two answers, I need two answers here. I see the degree screaming at me. I need two answers. So I can do this and try to come up with what I did here. I'll tell you ahead of time, I've got just a few minutes here, it's not going to work. This one's not going to factor. But yet it's a quadratic. Trying to lead you into something we may have seen before. So guys, this one, I love what she gave me here. It's not going to work. It will not work on this one, but yet I'm supposed to find two answers. So what should I turn to if it does not factor?
Quadratic formula.
There's something called quadratic formula, and students love the quadratic formula. If there's one thing you enjoyed back whenever you first saw it, you probably enjoyed the quadratic formula. First, what does that quadratic formula look like? X is equal to what? Negative b plus minus square root b squared subtract 4ac all over 2a. That's a formula we have to accept. It's called the quadratic formula. Now, we've reserved this mostly for these that will not factor. By the way, if your factoring skills are weak, and I hope they're not, but if they are weak, you could use that formula back here on this one. And you'll get the same answers. And not factor. But this one has to be, the quadratic formula has to be used. Now you say, Professor, I've been out of school for a while. I don't quite remember. Well, let me remind you, that coefficient, they call it the coefficient, out front is the a. The b is -4. And the c in that quadratic formula is a -1. So guys, the a is 2, the b is -4, I'm looking at coefficients, and then my c constant is -1. So when I make my replacements here, it's going to look like this. X is equal to, go back to the red here, negative, looks like b was a -4, plus minus square root, b squared, b is -4, subtract 4 times a is a 2, c is a -1, and the formula says place all that over 2 times a, and my leading coefficient was a 2, and I just made replacements directly from here. A is 2, B is -4, C is -1. Have to plug those in. Now I got to clean this up. We're going to take a break here. I know and you know that turns into a +4. Negative times a negative. where I see some of my best students making a mistake is the next part coming up. Underneath that square root, this is where students mess up if you're not careful. This much, right here, -4 when you square it is 16. That's not the hard part. Where I'm concerned, as an instructor, is you also have this remaining part underneath there. So I like to think of it as that remaining part as -4 times 2 times -1. What is that remaining part, that product? -4 times 2 times the -1. All those numbers multiplied together will give me a what?
-8.
Positive, as negative, positive. I got a negative times negative, positive, +8. Here. Now I'll come back to it. All over, of course, that's 4, 2 times 2. We all agree? Okay, here we go. 4 plus minus, I'm not quite finished yet. Square root of, I need to put those numbers together. 16 plus 8, 24 underneath that square root. All over 4. Now, we'll take a break here. I wish, I'm sure thinking that you wish, that this had been a 25. Right?
Yeah.
Square root of 25, that's 5. It's not 5. It's not 25. It's a 24. So that means, Professor, can I do anything else with it? Well, that's where I want to ask my class here. 4 plus minus, yes, there is something I can do with 24. It's not perfect. Help me out.
2 root 6.
He says quickly, Professor, it's 2 root 6. Now, for those of us who have been out for a while, you say, Professor, how did he get that so fast? Is he smart? He probably was thinking of it like this. Square root 4 times square root 6, that's square root 24. And this much is a perfect square root thing, because that's 2 radical 6, and he says it right quickly, right there it is. So I could do something with square root 24. I could break it down. Some square roots you can't break down, but this one you can. Now, am I finished?
No.
No? Can it be reduced down? Yeah, I'm looking at these nice numbers that came out. All those numbers, just arithmetic, can all be reduced down by 2. I can divide all those numbers by 2. 4 divided by 2 gives me a 2 here. This 2 divided by 2, of course, gives me a 1. And down here, 4 divided by 2 is 2, guys. I've reduced all those down by 2. Is that true? I didn't make a mistake, did I? Did I make a mistake, or is that it? Did I reduce it down correctly? Look at it closely.
No,
Has it been reduced down correctly?
I don't think so.
Okay, what's right here? This number, this number, and this number, can I divide all of them by 2?
Yeah.
So 4 divided by 2 gives me what?
2.
2. 2 divided by 2 gives me
1.
1. There should be a 1 here. And I gotta do it down here also. I gotta do it to all those numbers. 4 divided by 2 down here is 2. Is that true?
Yeah.
Is that true now? Has it been reduced down by 2? Now, if it has, then we'll take a break here. Can anyone tell me, I like to place my answers when I start getting strange answers especially. I like to place my answers in a set. I will separate these. There are 2 answers here. It says 2 plus minus. Let's consider the plus first. I've got 2 plus radical 6, the way I left it here, over 2. Do we agree? Then consider the minus. If I can now consider the minus that was right there, I've now got 2 minus radical 6 over 2. There they are separated with the plus minus. Please tell me, do I have 2 answers? I had to get 2. It was a quadratic, I had to get 2. Now I know right now, before I take a break, some students may say, Professor, I see another way I could write the answer. Can anyone tell me, at this point, another way that you could write the answer? I like the one I have on the board here, but I see Can anyone see right here, maybe this right here, could you rewrite it in a different form than what I have? And I probably would have to accept it. Yes, sir.
You put it as like a decimal,
So again,
as a decimal?
oh, no, we're not gonna use those calculators and get decimals. But can you do anything else with, now it may look a little strange, with this, I think this looks nice and clean, but can anyone see something else that you could write here and actually be the same answers, but it's a different form? Go for it.
I think it would be 2/2
Beautiful.
plus,
Here we go.
plus rod 6/2.
Look at that. She says, Professor. And sometimes the textbook will do that. She says, could you write your first one like that? Just split them up. You could. This and this are the same. And who knows what form they want in the textbook sometimes. If that's true, I can even do better than that. 2 divided by 2 that she gave me, I could call 1. So all of a sudden you see this. And more than likely they'll do the same thing over here on this one. And then may have the answers expressed like that. I like that. I think it looks cleaner like this. But sometimes you'll do problems in the textbook, you turn to the back of the textbook or wherever you check the answers, and all of a sudden you say, Professor, I thought I knew what I was doing. You had this, but you did know what you were doing. But for some reason, the textbook had it written like this. And that throws students off. They'll say, oh, I missed it. You didn't miss it. They just placed this in a different form. Okay? So guys, a couple of quadratics, linears, we're gonna work more of those when you get back from your break, and then try some of these longer, more detailed problems. We're not gonna hold back. So get ready.